good morning and welcome to this course which is called Sound and Structural Vibration. So, there are courses which deal with just acoustics, that is sound, where the PDE, the partial differential equation related to sound, which is of the form is studied. Okay. Once the sound has been made and it is available in the medium, it is governed by this partial differential equation in various geometries. This is studied in courses which are pure acoustics. Okay. And there are of course courses on vibrations of systems, vibrations of say plates and shells. Vibrations of continuous media. Okay. So, there are plates, okay, flat structures of various geometries that vibrate up and down, okay, and they are placed in vacuum. That is the idea. So, their equations governing their motion are derived and studied. Okay. You could have plates, you can have shell type structures that vibrate. Okay. Now, this course deals with how vibrating structures, the structure is a mean line and this is vibrating or carrying a structural wave. Now, this radiates sound into the medium. Okay. This radiates sound into the medium. So, how the structure radiates sound, how the structural vibration radiates sound, okay, is the addition to this course, the next level to this course. Okay. So, which means what? You have to deal with the structural equation, okay, structural vibration equation, and you have to deal with the acoustic wave equation, okay, and the coupling between the two, okay. So, let me just first say that this is a course at the level of either final year masters, students and PhD students. Okay. It is not at the level of bachelors, and there are prerequisites. That is, one should have had a course in fundamentals of acoustics. And a course in vibrations of continuous systems. Not lumped vibrations like spring mass dampers. Okay. You should have had a course in vibration of continuous system, which is plates and shell type structures. Okay. It is a prerequisite. Now what are the texts? The texts that I will follow, many sources first of all. Okay. And so amongst those sources will be journal papers, okay. Then in portions I will follow a textbook called Sound and Structural Vibration, radiation, transmission, and response. The name of the text, okay. It is written by Frank Fahey in the very initial edition, and I think now there is a second author, Paolo Gardonio. This is one text I will follow in portions, okay. And then there will be some notes of mine, okay. There are other texts which are useful, or one textbook I suppose, it's called Sound, Structure and Their Interaction. And by authors Younger and Feit, F-E-I-T. Okay, this is a text you can refer to. Okay, now just to give you a flavor of how I will proceed, I'll begin with what I call a classical problem. In sound structure interaction. Which is an infinite panel or infinite plate, okay, that is vibrating or carrying a wave as it is excited at one point by a line force. Okay. So this will generate vibrations in the plate and it will generate sound in the fluid medium. Okay. There is a acoustic fluid on one side, there is vacuum on the other. Now this fluid in turn applies the pressure back to the structure, and so this is what we call a coupled problem. We will analyze this using analytical methods. So we will find analytical solutions. Okay, using asymptotics and using contour integrations in the complex plane. Okay. Then I will move to a system called a waveguide, a structural acoustic waveguide, where there is a fluid of a certain column height extends to infinity in the other direction. It is covered by a rigid wall on the top. In the lower wall is a flexible plate. Okay. So now we will examine the interaction of this flexible plate with the fluid, how they influence each other's behavior. Then we will follow this with a box with a flexible panel on the top that vibrates, and it interacts with this cavity where all the other 5 surfaces of the box are rigid. Okay. We will examine the coupled response of the panel and the fluid medium when they are excited. That is the third problem we will look at. This will be followed by a traditional problem, which is a radiating vibrating plate. Okay. Vibrating plate in a baffle or a rigid wall. Baffle is a rigid wall. Rigid wall. So this plate vibrates, okay, and it's placed in a rigid wall of infinite extent. This rigid wall extends to infinity, whereas this plate that is vibrating is finite. Okay. So we will proceed along these lines, and a few simpler topics or a few smaller topics. Hopefully it will be useful to you. Thank you very much.